Well, a pain in the butt. I just recorded this video and apparently it didn't actually start recording. So, anyways, here I go again. So, when I was a part of my PhD was making a low-cost open-source metal 3D printer, and this is what the end effector looked like as kind of a sketch. So it used TIG welding as its extrusion method, or its deposition method rather. Uh, and so what that looked like is you had some sort of torch that would emit a kind of a controlled current arc, and when you put material like metal into that arc, it would melt and basically meld with the metal substrate beneath. So this is fine and dandy because it's all pretty low cost, which is nice, and easy to replicate. You don't have to have like lasers or anything like that. However, one thing that probably won't come as a surprise, especially if you know welding, is that when you weld, when you're TIG welding, you have a direction that you're going, and usually you are feeding from that direction. So if you're heading to the right, you are feeding from the right. And so you can see here, when we're heading in this direction, or how I indicated in the sketch, print direction, we're feeding from the right. So kind of a downfall of this is that it does have a very strongly preferred print direction. I tried going in other directions just to test, just to see if I might be wrong, and I wasn't wrong. It doesn't test in any, or doesn't really go well in any direction other than its preferred direction. So that kind of creates a problem because most slicers out there are made for going made for printers like FDM printers that can go any direction they want, up, down, left, right, zoom, 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 and it can extrude all while doing that. But I couldn't use that. So even though I'm still working on the same G code, and I even have the extruder hooked up to the same extruder motor, or the same extruder driver on the 3D printer that I was using, I wasn't really able to use a normal slicer for this. And so what do you do if you don't have a slicer but you want to start being able to make models? Well, one thing you can do is start writing G code by hand, but that gets really tedious the moment you want to start changing things, right? The moment you want to say, oh, I need the feed rate to be bigger, and you got to change it all over, and you might have to change your extrusion rates. It's a pain in the butt. So something I'd done is, and once again, disclaimer, I am definitely not an all-star programmer when it comes to like computer sciencey related stuff. More of a firmware guy. But anyways, so if you see some flaws in this, I'll post the link so you guys can view it. But if you see some flaws in this, please point them out, because there probably are definitely there. And the biggest flaw is I know that there's better ways to do this, because I just needed to get something done. I needed to get something that worked, and I needed to exploit my skills or what I knew I could do. And that was basic image processing stuff, or being able to parse an image. So my idea was this. I would pre-slice things. I would basically draw sketches in just some sort of bitmap editing software, and a black pixel would mean deposit material, a white pixel would mean don't deposit material. And so here you can see this whole shape is filled with material. Same with this shape. But now there's a little less material, a little less material, a little less, a little less. So what this was basically, like I said, a pre-sliced set of layers saying what this looks like along some sort of Z step that was predefined. And so now I could go through and edit and just say, oh, I need a little bit more material here, less material here, so on and so forth. So what that code looked like, right, it was written in Python. And of course, I had some functions like creating just a straight line of extrusion. And I'd ask, say, hey, how many layers are there? Each image was a layer, is the way I designed it. And I'd say how big is a voxel in the x-axis and the y-axis. So basically saying when I have a pixel on my image, how much material should be deposited there, right? Is that 10 millimeters or is that just 1 millimeter? And I designed it to be 1 millimeter, just because it made the math a lot easier. Anyways, and so what would, like I described, what would happen, say like in this image right here, is it would start at this bottom left pixel and say, oops, there's no extrusion, no extrusion, no extrusion. Oh, I see a black pixel. So I'm gonna, this isn't a starting point for I'm gonna extrude a line. And then I'm gonna go, okay, counted 1 pixel, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 30, 35 pixels. And then I see white, and that means I need to stop that extrusion line. But I don't hop over here yet because I wanted to be as flexible as possible. Maybe I would start another line if there was black material right here. I think one of the test images I did was something like this guy here, right? Some kind of obscure random shape, or this is another one I did. This is a really small thing that I made to test basically every possible case that I could have happen. Anyways, so what would happen is it would go through layer 0, 1, 2, 5, 6, 7, 9, and I would have it also move up, and then it would all add this into an output G-code file, right? An output G-code file. And like I said beforehand, previously I was writing these things. You know, I was writing them by hand. And so that would mean a lot of my things would just be cubes and things like that. But now, right, this is all pre-generated for me. And you see it's pretty much all this G1 movement, of course, for putting it in G91 mode to start off with. Now, a handy tool that I used a lot when I was prototyping the software was this ncviewer.com, something handy that you also might want to look at. NC, I believe, is an extension for other G-code files. Anyways, so what I can do is I can paste in my code and then boop. So you can see now kind of what my shape, here's right off the side, what my shape is going to look like. And it's not, so you can see there's this little ding here. So this is showing the toolpath, but it's not actually showing where the extrusion was. And so there was no extrusion there. I didn't actually start the extrusion until that point. But you can kind of see the overview too. Yeah, so it's kind of, this is just a handy tool, especially when you're making custom G-code utilities, to actually see what your G-code is going to look like. I'd say this is especially useful when you're doing things like milling, but also anytime you're dealing with custom G-code, it's really handy to be able to look at it. So anyways, I just thought that me showing you this, right, obviously this isn't as glamorous as something like Cura, but it definitely gets the job done for what I needed it for. And it's reasonably approachable for those that have never done anything with slicers before to kind of understand this compared to the more complex algorithms that are used by modern slicers.